All right, good morning, everyone, and welcome to re:Invent 2024. Hopefully, you guys are having a lot of good time and enjoying yourself. True to the learning experience of re:Invent, in this session, we'll walk over some of the innovations that we have been introducing in our detection and response services. AWS provides a wide array of native AWS security services across multiple different use cases and domains. This session, SEC321, is focused on what are some of the key features, enhancements that we've been bringing along the time in our detection and response portfolio of services. My name is Himanshu Verma. I lead the team of our identity and security specialists at Amazon, and I'm joined with...
I'm Ryan Holland, and I lead the Amazon GuardDD team.
So, pretty straightforward agenda today. The topics we'll cover is to provide you an overview of our detection and response services, provide new features and capabilities that we have launched since the last time we talked about these services at this event. And then also there'll be some demos involved. So we'll probably try to make it as immersive as possible. Our detection and response services, when we talk to customers, help solve some of these key challenges that customers want with their business outcomes. First and foremost, I think the first thing front and center is to protect AWS workloads. All these services, the primary focus of these services is to protect AWS accounts, workloads, and also measure security risks effectively and then take actions on them. We also hear from customers that they want the ability to centralize so that they can monitor any vulnerabilities, any risks, and have full visibility across their AWS environment using some of these detection services. And then we've heard from customers that they want easily able to aggregate the data that's needed to investigate and do root cause analysis, especially whether it's the security operations teams or security personas at customers who want to jump in, the security engineering teams who want to orchestrate workflows, and then unlock some of the security innovations using either generative AI or machine learning throughout these services. Our detection and response portfolio of services are categorized into these three key subcategories. The first one is threat detection and workload protection. One of the primary services that we will talk about is Amazon GuardDD, which is primarily focused on helping customers identify threats, anomalies, suspicious activities. So we'll focus on that. The second category is vulnerability management. We classify vulnerabilities as not just open source vulnerabilities or software and operating system vulnerabilities, but also potential risks, misconfigurations, et cetera, all in this category. So some of the services that we have that help customers here are things like Security Hub, as well as Inspector, which have been innovating to improve not only the security team's experience, but also the developer experience as code is getting written or containers or EC2 instances are getting launched. And then the third category is investigation and response. Here, our focus is to help customers orchestrate all the data that's needed to dive deeper into security issues, effectively run queries, and get insights, rich insights from that data. Before we jump into our services, actually, I wanted to also provide some insights into how AWS is striving to make the global internet as a safer place. We have a lot of infrastructure and scale, as you can imagine, and with that comes the ability to detect and have insights into what is happening in the global threat landscape as well. Some of the services that we will talk about today are actually powered by this infrastructure, which is where we collect unparalleled insight and telemetry, and then use those rich insights to either apply machine learning, neural networks, heuristics, and then use that same insights into our services themselves. I think we've heard this phrase before, not all clouds are built the same. And when it comes to security of the cloud, that's another area where we actually are passionate about these investments. One of the first key investments that we made in our global infrastructure is around threat intelligence. This is something that we strive to actually build a neural graph network of domains. As you can imagine, like we see a lot of bad traffic coming in from the internet. on Amazon as a whole. And that is where we apply some of the machine learning and artificial intelligence to ensure that the domains that we are looking at are actually the ones which are malicious or bad, and then we can feed that information back into some of our services. This requires inspection of trillions of DNS requests a day, and then discovering a lot of malicious domains per day as well, and then feeding that back into our services like GuardDuty. When it comes to detecting threats, we also have a wide infrastructure of sensors that are deployed all across the internet. And these sensors are collecting a lot of data and are also decoying the bad actors into sending information. We've seen some like time frames where as soon as a resource is launched in AWS, within about 90 seconds, we start seeing probes and hits to those resources. So these sensors are actually bringing those bad actors, and then we are collecting all that information and then feeding that back into our services like GuardDuty, Inspector, Web Application Firewall. And then finally, not only detecting, but we are also focused on threat disruption or automated threat disruption. What's happening is that as we collect all this threat intelligence and we create this neural network to actually remove false positives for bad domains, bad IP addresses, we are also automatically ensuring that customers' workloads are protected from botnets or crypto mining or cryptojacking. So services like S3 or services like VPC and our native security services are using these same techniques that are invested in the overall infrastructure of AWS. This is again all to ensure and strive that the global internet as a whole is a much safer place for all of our customers. Now, when we go into our specific services for the detection and response portfolio, these are our 6 key services. First and foremost, all of these services are natively integrated with your AWS accounts, which means they require no operationalization or orchestration when it comes to protecting your accounts and workloads. Also, most of the times I tell customers, and there's a misconception that because these are detection tools, they require telemetry, and hence customers have to go enable logs. This is another key factor, that none of these tools require any log enablement or API operationalization. All customers have to do is enable these at the account level, and then these will automatically then start protecting and detecting findings and provide insights. So one of the core services is Amazon GuardDuty, which is focused on monitoring log activity from flow logs, API activity from CloudTrail, and also now monitoring host activity with using runtime protection, and then providing findings where we see a match for either a bad IP address, bad URL, fed in through that threat intelligence that I mentioned, and also using anomalous or suspicious findings to provide insights to customers. Amazon Macie is our primary service that's focused on providing customers with rich insights on sensitivity of or risks associated with sensitive data. So you can use Macie to actually get insights. It's natively integrated with Amazon S3 and the objects in Amazon S3 as to where are some of your sensitive objects, sensitive data, and then what are the current risks associated at the account level or at the organization level with all the objects that are there in your buckets. Amazon Inspector is our service that's focused on vulnerability management. Over the years, we've actually scaled the service to now include multiple different AWS workloads that can be scanned for vulnerabilities, and it also ingests a large telemetry of a vulnerability database that is actually what's being leveraged to then provide customers insights into those findings. All these services provide findings, which is different from logs or APIs. So these findings are actually JSON objects, which are available in the event bus queue, event bridge. And from there, either customers can stream these findings to their centralized security operations tools like a SIM tool or a SOAR tool. Also, we aggregate all these findings with rich insights into Security Hub. Security Hub is our centralized monitoring tool So first and foremost, it allows customers to aggregate all the findings, not only from AWS native security services, but also from our partner tools at one place. But more primarily, what it does is cloud security posture management, which means that it's continuously evaluating controls in your AWS accounts and workloads against a set of standards that we've actually built internally, or AWS foundational security best practices, or external standards as well, such as the NIST or CIS benchmarks, etc. Those misconfigurations or deviations from security best practices are also reported as findings in Security Hub. So that provides you one place to now orchestrate automated response actions and or take remediations from there. Amazon Detective is our service that's focused on building a graph database to help customers correlate insights into all the findings that are there in Security Hub. So if you want to know what is an entity or a node, such as an instance, and what all are the different attack vectors on that instance, Detective is one place where you can go in and explore that graph database both visually as well as look at all the detailed API calls. Again, all without actually having to enable the logs or parse the logs yourself. And then finally, over the years, we've actually launched a new service called Amazon Security Lake, which helps customers manage all the different logs that are needed. We do recognize that security teams do at times need to organize logs for deep down analysis and running queries for security engineering purposes or security analysis, and that's where Security Lake comes into picture. Security Lake actually helps customers organize and centralize all the data easily without creating multiple copies of these logs and or losing access to these logs in partner tools or third-party tools. And then also provides you to be able to innovate and gain access to future technologies like building your own generative AI capabilities on top of those logs. So as we go through these services, we'll dive into the details of each one of them and what are some of the new features and capabilities that we are launching. In addition to being natively integrated, one of the other key value propositions that these services provide are they're all natively integrated with AWS organizations, so helping you deploy these services at scale and also automate some of those processes. Each one of these services are integrated with AWS organizations, allowing the security teams to designate or delegate a centralized management account so that not only can you easily aggregate all the findings from those services in that security account, but you can also manage new member accounts that are coming to the organization, can be automatically enabled with these services, and also you can onboard and offboard member accounts easily from that centralized delegated management account. So just to show you how this works real quick, I will switch over to the demo portion of this. This is a screenshot, or what you see here is GuardDuty console, and each one of our services actually in the detection and response domain have this accounts tab. This is where a centralized management account can go in and delegate an administrator account. And once you've done that, each one of the member accounts can then have an option similar to this. We've made this super easy, one-click option, where, like you can see, as we are scaling GuardDuty's protection plans, which you'll hear about in a second, there's an easy option to either enable all these for your current accounts, as well as you onboard new accounts, you can be free of worries, so that as a security team, you can easily enable these for also new accounts as well as you bring them in. Also, you have the choice to choose, do you want to auto-enable them for new accounts, or you want to go in and select specific accounts and enable those as well. So these are, again, one-click options that are available that you can easily choose either by individual features or overall for all of the features that are available in the service like GuardDuty. Also, all of these come with a free trial. We've actually made sure that all these features and services come with a free trial so customers can actually try it. One of the other things that customers like or love is that we have a usage tab that provides you visibility into what would be the potential cost implications of using that service over a period of time, and you can get that insight during that free trial period as well. Moving back, I'll hand it over to Ryan to cover the threat detection and workload protection portion of this session.
Thank you very much, Himanshu. So the threat detection and workload protection component, as Himanshu mentioned, is Amazon GuardDuty. That's our service that provides threat detection. And at a very high level, GuardDuty is a threat detection service that uses multiple different detection techniques in order to identify potential compromises of credentials or workloads within your account. So we're not just looking at the accounts themselves, but also looking at the workloads that you're running to identify suspicious activity, like Bitcoin mining or connections to command and control servers or other indicators of compromise of the workloads that you're running, as well as suspicious activity that takes place on the control plane with things like CloudTrail. So to go a little deeper in how this works, and just give an idea of how we've scaled this service over the years. When we launched GuardDuty at reInvent here in 2017, we had the foundational data sources that you see in the top. And GuardDuty primarily acts on log data. And as Himanshu was mentioning, one of the key advantages that we have is you don't have to configure or enable any of these log sources. As soon as you turn on GuardDuty, we get this log data from our internal backend source. So you don't have to configure it, which is nice from an administrative overhead, but it also has some security implications as well, as if somebody does get a foothold in your account, they can't interrupt our access to this data. And it also means you can't forget to enable something as well. So the foundational data sources are on by default for all customers. And these are flow logs, DNS query logs, and CloudTrail. And this gives us pretty broad visibility across the network activity of the instances in your account, as well as the activity on the API control plane. And then over the years, we've extended this and added additional optional protection plans. And these provide protections to other parts of AWS, other services that I'll walk through here in a minute. But regardless of which protection plan is providing the source, the first thing that we do when we get these logs is process them through multiple different analytics engines. So we look at these things at stateless, like in a rule-based manner, but we also have advanced machine learning models that look for anomalies across these different data sources. So looking for unusual activity in CloudTrail, like users logging in from unusual locations or performing activity that is unusual for that user or even other users within your account. One of the things that we've really strived to do on these ML models is identify suspicious and likely malicious, right? So not all anomalies are going to be malicious, but we try to look at these and tune these in a way that make it so we identify things that are more than likely going to be active threats. And one of the other nice parts about these models is we try to make it easier for the receiver of these findings to understand why we found these to be anomalous. So the newer models that we have now will include information about what we normally expected to see and why we thought what we did see that was different to help the first incident responder or the help desk person that's getting this finding understand what we saw that was unusual and why it was flagged. We also leverage threat intelligence. So we have our first-party threat intelligence that Himanshu was mentioning, our DNS graph database that provides us a large number of really actionable and newer domains that are malicious. So a lot of those 100,000+ daily domains that we're identifying are quite new and not generally available on third-party threat lists. We also do incorporate partners threat list as well. So we partner with CrowdStrike and Proofpoint in order to get third-party threat intelligence, and then customers can also bring their own threat intelligence if you have something you want to do as well. And then the output of these detection engines is a security finding. And we try to decorate these findings with as much metadata or context as well to help make them more actionable. And then we send them to, obviously, our console, but more often than not, customers will pick these up using EventBridge, which will allow you to trigger downstream automations or ticketing or to do response actions. And they're available in Security Hub. They're available in Amazon Detective to do further investigations. And then we have a large number of our Amazon Partner Network tools that also collect and help customers act on GuardDuty findings. And then one other response option that we've added over the last couple of years is malware protection. So with the malware protection, there are a set of findings that we've identified that are more likely to occur if there's a presence of malware. And so if one of those findings occurs on your EC2 instance and you've enabled the malware protection, we will snapshot the volume, run an offline malware scan against it, and then report any malware that we detect on there. So this can help you tie connect the dots between we saw network activity on an instance, maybe communicating to a command and control or talking to a Bitcoin server. And then when you can run the malware scan, you'll actually get the file path and the hash and the name of the malware and where it exists to help really speed up the response time. So I just want to do a quick overview of some of those additional workload protections that we've added over the years. So the first one that we added was the S3 protection. And this gives you visibility, or gives GuardDuty visibility into the data plane events. So in CloudTrail management events, we would see the S3 management events, but these are the data plane events like get, list, and put objects. And again, you don't have to enable this on your S3 buckets. As soon as you turn this on, we'll get visibility to all of the S3 data events within your account. And we'll start looking for things like unusual activity. So is this a bucket that we normally see a principal only writing to and suddenly it's reading lots of data? Or are we seeing unusual activity either volumetrically or from other factors like the location that it's accessing, or it's suddenly accessing a large number of buckets that it doesn't generally access. We also added EKS protection. So the EKS protection is very similar to CloudTrail in a sense that within Kubernetes, you have a Kubernetes controller, and with EKS, it produces audit logs that are the audit logs for access to the EKS control plane. And we have machine learning models that look for unusual activity like the unusual creation of privileged containers, or unusual role bindings that are being created, things that could indicate that maybe a credential is compromised and it's being used to impact your Kubernetes workflow. I talked already about the malware for EC2, but also this year at Reinforce, we extended this to S3 as well. So with malware protection for S3, you can enable this on select buckets. And if you enable it on a select bucket, we'll automatically get notified every time an object is written to that bucket, perform a malware scan, and then send you either a finding if there's a detection. We also send it out CloudWatch. But one of the more often used features is we can tag the object as well. So this allows you to have a data ingest pipeline. So if you are collecting data from customers through a web portal or third parties that are uploading data, they land in your bucket, they'll get scanned by GuardDuty, and the result of that scan will be applied as a tag. And then you can have your data ingest workflow wait for that tag to exist and only accept objects that have been deemed to be where there's no threats identified. RDS protection looks for anomalous logins and to your RDS databases themselves. So the actual connection to the RDS database, looking for people logging in from unusual locations or logging into unusual databases. We also have detections for brute force attempts, where people are brute force attempting the RDS login. Then we have Lambda protection, which extended our flow log detection to Lambda function. And this works for Lambda functions running it with VPC networking as well as standard networking. So if your Lambda function suddenly starts, maybe it has a compromised library in there and it starts reaching out to a C2 or a crypto server, we'll be able to identify that as well. And then one of the more recent extensions has been runtime monitoring. So we moved into runtime monitoring in order to get deeper visibility into the activity that's taking place inside the guest operating system and give us more telemetry than we could do with the traditional log sources. But when we did this, we wanted to do so in a way that really maintained the one-click enablement that we have with GuardDuty. So we built a very lightweight agent that's based on eBPF, and the agent itself is really a telemetry collector. So when you enable the runtime protection, we will deploy the agent for you automatically to EKS nodes in your account using EKS managed add-ons. With ECS for Fargate, we inject it directly from the Fargate side so you don't have to make any changes to your task definitions. We create the VPC endpoint that it's going to need for you. And these agents stream the telemetry to our backend, which is where we apply all of the content and the logic for detections. This also gives us the ability to do detections over streams of events. So looking for not just individual commands, but commands that by themselves might be benign, but in context with other future commands that we see an operator make become a more suspicious activity. And we continue to add new and more detections for the runtime protection as well. And then the newest thing that we've just released, it was announced December 1st, Sunday evening, is we're calling extended threat detection. And this extends our detection from looking at, instead of single or batches of events in short periods of time, to identify a single finding, but to more look at not just groups of findings, but findings across data sources, as well as additional other signals that we have that might not generate a finding on their own, but in context with some of this other data is very useful. And the idea here is when you have a credential compromise, there's not generally just one or two or three individual events. There's really a string of events, and they generally start and they follow the MITRE attack pattern, which is one of the reasons why we've mapped a lot of this to the MITRE attack as well. And when we look at these over time, we can get enough confidence to say that these are not just maybe individually suspicious events by themselves, but taken in concert. We now believe that this is highly likely that the credential that's being used here has actually been compromised. And so we'll generate a brand new type of finding just for that. So the first thing that's nice about this is it's on by default. So if you're already using GuardDuty, you already have this feature turned on. It also does not cost anything. So there's nothing to enable or configure. If you are already using GuardDuty or start using GuardDuty, you'll automatically be able to get these findings. The security value that we're adding here is, like I said, not just looking at the findings we've already given you, we're also adding some additional markers and context to these that go into a machine learning model that we've developed that can predict that based on all of the context that we provided, whether or not it reaches a threshold to decide that the credential has likely been compromised. So in addition to the types of findings that we're reviewing for that particular credential, we're also looking at other markers around the network itself, like is it from a VPN provider that our threat intelligence has told us we're seeing threat activity from threat actors. So there are certain VPN providers in the world that don't store logs, take crypto for payment, and that are more popular with threat actors than others. And so we look at things like that. Is it related to Tor? We have a bunch of markers that go into this that add additional context on top of the fact that we've generated some unusual activity findings for that credential that will allow us to say, hey, we think now that this is probably a compromised credential. And we deliver this obviously in the console, and we did a revamp on the console that I'll show you here in a minute to make these really easy for an operator to consume and to respond to. But also if you're consuming our findings through any of those other methods that I already mentioned, this presents itself as just a new finding type. One thing I will say about this finding, when we launched GuardDuty, we have severity across our findings, low, medium, and high. Numerically, they map between 1 and 8. And we always said we were reserving 9 and 10 for when we came up with the detection that we thought was worthy of being called critical. And so these new findings are severity of 9, and they'll have a critical tag on them as well. So there's 2 finding types that are associated with these. And the primary difference is what type of activity are we seeing more prevalent. So as I mentioned, if you compromise a credential, there's a set of API calls that we classify as higher risk that we tend to see threat actors try to exploit, like creating new users or creating new access keys, right? Establishing persistence. And then on the other side, if you have S3 data protection enabled, we'll also cross-correlate that across the S3 data plane events as well to detect things like ransomware or data exfiltration. So depending on which one of these is more prevalent, we'll give a compromised credential or compromised data if we're seeing this as primarily a data-focused attack. And then the findings, which I'll show you here in the console, we added a lot of rich context, and we map these to the MITRE attack, with not only with tactics, but also with the techniques as well. And they also include a human-readable natural language summary at the very top, which gives the first incident responder a very clear understanding of what happened, when it happened, what was involved, and why we thought this is something worthy of bringing to your attention. And then all of the resources that are involved in the attack. So as you can see here, this is the new improved summary page that you get when you load GuardDuty. One of the things that we've added here in this finding box is what we call top threats. So these are just prioritized threats across your organization. And then you can also go and say, I just want to see these attack sequences only. If you click up here on the attack sequences, also it'll bring you to the standard finding page and filter on those. So as you can see, I have a compromised credential detection here, and it has 8 different resources associated with it. This one only has 2 different resources associated with it, and then multiple different signals. So if I click on this view details, it'll also expand this out, which makes it a lot easier to view. Up here on the left, you'll get that human readable natural language explanation of what it was we saw, how many indicators we had, what were the number of resources that were involved, as well as the MITRE attack tactics and the different techniques that we saw, as well as a visual mapping that you can then go and click on and see the different findings that were associated with that MITRE technique and tactic. And then you can see the different indicators that we saw. So in this case, there was 4 different indicators, including high-risk APIs, the different tactics, the suspicious user agent in this case, the actors and the endpoints, as well as a nice timeline that gives you a visual representation of when we think this attack started, and then when it ended over the period of, and this could be over a period of hours or days, right? So as this attack sequence were to continue, if we were to see further activity that moved into privilege escalation, for example, it would be updated into this existing finding, and we would show on the timeline the further actions that took place. The other thing that you can see here is the resources that were involved. So in this case, you can see there's 2 resources, and this instance is involved because I used an instance role in order to generate this attack sequence. So an instance role was involved, so this instance is actually implicated, as well as the access key that was associated with that role. So if I look now at one for the S3, again, in this case, it's going to be somewhat similar, but in this case now, what was more interesting to our model was the fact that there was a large number of sensitive APIs under S3 that were involved with the other unusual activity, right? So again, you get this human readable explanation, the nice timeline that shows you when things began and when they ended, as well as the resources, which in this case are now going to include other things like the S3 buckets that we saw the malicious activity taking place in, as well as the instance that generated the role that created the finding, the access key, and then the other buckets. I'll hand it over to Himanshu for.
Thanks, Ryan. So as Ryan mentioned, like a lot of the information that you saw in that demonstration is all available in JSON events. A lot of our customers leverage tools where they also bring in findings from not just AWS detection tools, but like other cloud providers as well. And these findings can actually be used to enrich those signals that you might be, where you are aggregating all these findings. The second pillar that I mentioned earlier was vulnerability management. So moving into that, one of our primary services here is Amazon Inspector. With GuardDuty, you saw how GuardDuty is actually leveraging machine learning and bringing this rich insights to customers when it relates to threats as well as suspicious or anomalous activity. Amazon Inspector is actually focused on providing customers with visibility into, first and foremost, what all is their software bill of material, which means in your accounts, where all are the instances, container images, Lambda functions, etc., and then also keeping a snapshot of that bill of material, and then providing customers the ability to then scan these workloads for any open vulnerabilities. We've also strived to align Amazon Inspector to the shift left mentality, which is helping developers ensure that they're writing secure code to begin with. So Amazon Q Developer, which is our GenAI-powered tool that helps developers write code, also uses Inspector APIs to be able to do vulnerability management when code is being written, and it can also recommend to developers that they're calling an open source library, which potentially is vulnerable, and then they should look at the recommended lines of code to replace that and fix that vulnerability as well. Inspector, again, is focused on the same area of one-click enablement, but over the last several months, we've actually continued to scale Inspector's capabilities. First and foremost, as I mentioned, the bill of material is available. When Inspector is enabled at the organization level, it quickly brings in a snapshot of all the resources that it supports. Also, over the period of time, we've enhanced Inspector from its earlier version. Inspector was actually one of our very first native security services that was launched even before GuardDuty. But when we launched that service, it had its own proprietary agent that was required to scan EC2 instances. Now we've actually scaled that and removed that friction, and it now supports agentless scanning for EC2. And that's something that's available in the newer version of Amazon Inspector. Also, we've given customers the ability to scan container workloads, especially ECR container registries, where you can choose to either do continuous scans or scans only on push of these container images or events. Not only does it do operating system level scans, but it can also do language-based scans. So if you're using any of the scripting languages, it can also identify vulnerabilities within those. We've also introduced CIS scans or on-demand CIS scans, which is the CIS benchmarks that can be leveraged to also compare the vulnerabilities that are reported in the findings. And over a period of time, customers asked us that can they get not only the ability to scan these reactively, but proactively when they're pushing code to their code repositories or provide them with either APIs or plugins that integrate with their code repositories. So we provided CI/CD image scan plugins that can be used by developers to easily scan vulnerabilities when they are pushing those to code repositories. Some of the key enhancements that we've done here is now leveraging generative AI to automate and operate our security services as well. We've enhanced our Lambda code scanning, for example, in Inspector to not only provide customers when the findings are reported, what lines of code do we believe the vulnerability is in, but we also recommend what would be the potential remediation of that vulnerability by providing GenAI-powered lines of code that can be used to actually easily remediate that. So when that finding is actually sent by the security team into a ticketing workflow or back to the application team, usually you can actually then include that recommended lines of code for the development team as well. And just to show you real quick how this works with an Inspector, as I mentioned earlier, again, there's the same things that you will see in all of our services, which is accounts as well as usage, which can be enabled at the org level. But once Inspector is enabled, within a few minutes, it'll actually bring all this inventory. One of the key things that customers appreciate is the environment coverage graph that tells you on how many accounts within your organization you have the service enabled, and then how many of the instances, container images, and Lambda functions are actually covered by Inspector's vulnerability management. We also provide you a risk-based remediation view. So for example, what are some of the packages where we see most of the vulnerabilities so that you can easily prioritize what are some of the images or containers, repositories where you need to go take actions on. This is where we will give you also some of the accounts with the most critical findings so you can easily go in and take actions on them. One of the key features that Inspector also provides is not just providing vulnerabilities, which is matched by a CVV or an NVD database that we maintain by collecting signals from about 40 different sources, but also there is a finding type which is very useful for customers, is called the network reachability finding type. So when I look at the finding types here and look at network reachability rather than package and code vulnerability, what it's telling you now is that these are some of the impacted resources which are reachable to the network, and it also provides you the path of what is the path that they're taking or what is the open network path that can be remediated. So this is again being leveraged in context with the severity of the vulnerability to elevate the Inspector finding score and provide you more rich insights so that you can easily take actions on those high priority items. And then you can export software bill of materials in common formats like Cyclone DX or SPDX And you can also export these and automate these to an S3 bucket. So you can create a snapshot of time. So compare like what resources have been launched when, by which application or business team. And using some of the resource tagging, you can also then find out where you are finding the most vulnerabilities in that software bill of material. So moving on, one of the other things I wanted to highlight was our centralized monitoring and cloud posture assessment service, which is AWS Security Hub. All the findings from Guard Duty Inspector will go into Security Hub automatically, but Security Hub is also focused on evaluating controls in your AWS account and workloads. As your AWS accounts grow and your application teams and business teams are launching new workloads, what Security Hub is doing automatically is that it's evaluating these controls and matching them against security best practices. As I mentioned earlier, there are already standards built in which are categories of these controls to provide security teams an easy summarized view of what is the risk score, for example, against that standard. So AWS Foundational Security Best Practices is an internal standard, which is a grouping of 200 plus of these controls and growing, where we provide customers the misconfigurations or findings aligned to where we see potential misconfigurations. We've also added external standards like NIST, PCI DSS, and CIS benchmarks, which includes these important controls as well, and then the findings that are deviations from those control best practices. And as I mentioned, you can also ingest findings from partner tools. You might be using endpoint detection or EDR tools, as well as network firewalls, etc. You can bring in those findings all into Security Hub as well. These finding integrations then allow customers to then automate response and remediation actions. One of the most popular AWS solutions that is available in our solution library is the Security Hub Automated Response Runbook. That is essentially a runbook that customers can easily upload and or create their own custom CloudWatch actions and then take multiple different response actions. Security Hub also integrates not only on the ingest side of findings, but what customers want to do downstream. We recognize that most security teams want easier workflows for automation, such as either with ticketing tools like Jira or ServiceNow or open Slack tickets. So all those integrations are actually natively available in Security Hub to automate some of those workflows and streamline downstream actions. We got asked from customers about some of the features such as central configuration of Security Hub. So this is a feature that was recently announced, which is now available out of the box at the organization level. Again, Security Hub is again the service that can be integrated with AWS organization for multi-account management. But what customers needed was a central configuration place so that they can apply that configuration to either all accounts or group of accounts and maintain that risk posture or policies. So this is now available in Security Hub. Again, in the Accounts tab, you can easily go in and streamline and simplify how you want to set up and administer Security Hub by creating and applying these security policies across either a group of accounts, which could be your developer accounts, or a business team that has different requirements when it comes to risk and posture assessment. Another key requirement that we've announced now in Security Hub is the ability to configure some of these control parameters, which is customer-defined inputs to Security Hub controls. As I mentioned, Security Hub has controls that are built in, and we continue to add more and more controls as we launch new workloads, such as Amazon Bedrock. So if your application teams want to leverage generative AI or foundational models from Bedrock, but they want visibility on the security posture controls around that, these are some of the new controls that we will continue to add and enhance automatically. But what happens is that customers often need the ability to customize these controls based on their environment or based on their, how their AWS workloads are orchestrated. Sometimes, even the ports that are in the controls might be needed to be customized. So you might not be using port, 22, rather might be using port 47 or 67. So you can go and now edit these conditions by control in Security Hub, and then deploy them across all your accounts as well. So this is another new feature that's now available in Security Hub. Moving on to the third category, which is investigation and response. I think I highlighted how we are using machine learning to power some of our security services, how we've started using generative AI in our native security services, but we also want to highlight how we are empowering customers to be able to leverage Gen AI on some of our services as well. So one of the first services in investigation and response is Amazon Detective. Amazon Detective automatically, once enabled, starts gathering a lot of data from raw logs as well as telemetry from findings that are coming from Security Hub, and maintains that for about 1 year of time, and then automatically creates a graph database. A graph database is essentially a correlation of all the different common entities and touch points that we see between resources, which could be like around instances or workloads. So if guard duty is telling you that there's a possible threat in an instance, or we see a bad IP or a crypto and command type activity on an instance, and then the attack path, now you would probably want to know where did that threat originate, or for how long has that already been manifesting in your AWS environment. So Detective uses machine learning and creates a baseline on network activity and API activity in your accounts, and then also provides you where we see anomalies in the usage of those APIs or network activity. So using that baseline and comparing it against the baseline, you can easily then traverse open a graph of what all actions were taken to lead to that anomaly from that baseline. And you can go all the way down into API actions. Now, since it's bringing in a lot of this rich information, we also wanted to provide a visual view to customers so that they can easily view either on an attack path or also a visual graph database where you can easily go in and traverse open things like IAM roles or assumed roles, which are really difficult if you're a security engineer or a security operations trying to run that manually running queries, and can also look at all the puts and gets around data plane events in S3, etc. So this is where the graph visualization comes in handy. One of the key enhancements we've made in Detective using generative AI is to not only provide this visual graph, but as we group multiple findings around a resource or an entity, we can also provide a summary of what are some of the key things that you should be focused on. And this finding group summary is now powered by generative AI natively in Detective, where you can easily see human readable language that tells security teams which resource and what threat vector do they need to go and address and prioritize. Now, one of the key requirements over the years we've heard from customers is that they also want an easy way to aggregate their log information. This is actually a project that started working backwards from customers' requirements, where customers said not only do they need to easily aggregate this information, but they also want to really optimize the cost that goes in collecting all the logs for the security teams. And oftentimes when we would ask them what are they doing today, either they would be streaming these logs directly off to partner tools, or they will be creating multiple copies of these logs, either by one of the security teams or multiple teams, or also at times business teams who require these logs as well. So we launched a service 2 years ago, which has seen significant adoption and has been getting very positive reviews from customers, is Amazon Security Lake. What Security Lake does is that in a few clicks, when you click and enable the service, you answer a few questions around which all accounts do you want the service to be enabled, what regions do you want the service to be enabled, and where and how do you want the data to be aggregated by region or by account, and what all sources from AWS do you want to bring the data in. Security Lake will automatically, in a few minutes, once enabled, will aggregate and centralize all the data in your own S3 bucket using S3 lake formation in the backend, and will also orchestrate all that data in an Apache Parquet format and normalize it in what is known as now the Open Cybersecurity Schema Framework, or OCSF. OCSF is an open source initiative that we launched along with some of our other partners in the industry, and it has seen significant adoption over the last 2 years. This is something that we announced at Black Hat about 2.5 years ago, but now it has been revisioned into updated versions, and we see more and more independent software vendors, both from the security side as well as from the security analytics side, actively partaking in that. Because it's an open source schema framework, your applications and your consumer logs can also be transformed into that same schema format. And what that does is it allows security teams to now easily query these logs and have high performance on these logs when they are sent to partner tools like SIM or SOAR tools. So as I mentioned, this is, again, does not require any ETL or transformation for AWS log sources. One of the other key values that Security Lake provides is that not only can you bring in logs from AWS log sources without actually paying for ingestion of those logs, but you can also bring in all of your other logs as well, from other enterprise applications that you might be using, from on-premise sources that you might have, or from other cloud providers as well. And this can all be then normalized and transformed into that standard format. There are two constructs in Security Lake. One is what we call data sources, which is how the information comes into Security Lake. What you see on the top is the growing list of AWS log sources, and in the fullness of time, we plan to actually support all AWS log sources into this lake so that customers can easily leverage all of them in one place. Also, you can see the growing list of partner sources, which are obviously not the full list. The full list is available on the documentation, but this is all the enterprise applications that you might be using, or you can use partners here that I mentioned, like Cribble, et cetera, and create a pipeline of log sources from other cloud providers or application logs as well to come into Security Lake. Now, once the data is there and it's organized, that's when it allows you the full control and flexibility to do what with these logs. Just to show you how this information looks like, and once it's set up, this is a view of like my Amazon S3 bucket where I've enabled in that account Security Lake. What you see here is that I didn't have to do any of this organization or orchestration. Automatically, there are folders that are created based on the source logs. So these are all the AWS sources. If I click here, these are all organized by the logs that I've selected to come into Security Lake. You can see all the API activity, CloudTrail, all the flow logs in VPC, EKS audit, Route 53 DNS, Lambda, WAF. These are all supported by Security Lake. Also, all the findings from Security Hub can be brought in as well so that the security teams can easily query not only the logs, but the associated findings in that standard OCSF format as well. Going back into that same bucket, not only are there AWS logs, but there's also external sources that I might have integrated as well. So as I add some of these custom sources, either from our partner tools or bringing it from other cloud providers, that can easily be integrated as well to bring in those and then correlate them all in one place. This is all done automatically on behalf of the customers. So one of the key values that Security Lake provides is to take away the undifferentiated heavy lifting that goes in organizing and orchestrating these logs. There are absolutely no lambdas or step functions or ETL required to bring in this information into Amazon Security Lake. Once the information is there, now there's tons of flexibility for customers to actually leverage these logs. Either you can start using AWS analytic tools like Athena, and you can actually go into your Athena account right away and start querying these logs as well. Or you can use OpenSearch, SageMaker, a lot of AI, ML, and Gen AI innovations happening around the security industry. So you can actually put Bedrock on top of these logs and write your own Gen AI applications for your security teams to automate these workflows. And more importantly, use our partner tools, which you might already be using. But the big difference here is that rather than streaming data straight into these third-party tools and incurring egress costs or paying for data transfer, you can now decide, maybe for threat analytics or runtime analytics, you might only want to send 30 days and 60 days worth of data down to these partner tools, and then maintain the overall life cycle of that data in Amazon S3 where it already resides. It also makes making security policies and who all has access to these logs very easy, because now it's all centralized. So you can also choose which log sources go to which subscriber accordingly as well. So this list of growing partners on the analytics side is also continuing to grow. They all now support OCSF. And a lot of these partners now also support in-place federated query access, which means you don't really even have to move the data over to the partner tools. Just like in Athena, you can query these logs in real time. Some of our partner tools and some of the primary SIEM or SOAR vendors now support that federated query access as well from Security Lake. And just a couple of days ago, we introduced Amazon Security Lake's own integration with OpenSearch Zero ETL. This allows now customers to easily connect the data source in Amazon Security Lake to OpenSearch and create your own custom dashboards or some of the built-in dashboards that are provided for VPC Flowlog or CloudTrail that are easily available in OpenSearch. One of the key value propositions there is that OpenSearch supports now with serverless and zero ETL OpenSearch, so that does not require additional compute and or cost associated with that. And then one of the newest services that we just launched or announced 2 days ago is AWS Security Incident Response. We want to make sure that customers have the full flexibility and security when it comes to answering questions related to security incidents. This is a service that Amazon has actually been providing to all of our customers who are part of the enterprise support plan. But starting this week, we're now providing fixed SLAs and also providing the ability to automatically triage some of the findings that we find with Guard Duty or Security Hub. So if customers need help with triaging these findings easily, they can leverage AWS Security Incident Response. This is a human-powered service powered by the Customer Incident Response team at Amazon. So when you log a Severity 2 ticket, in this case, the service will automatically provide you visibility into what is the status of your ticket. You can also define your incident response team, their roles, the permissions, and how you want to communicate with that CERT team, which is the Critical Incident Customer Incident Response team. So this allows now customers to be fully aware of everything that's going on in their environments. If you are in doubt, we obviously encourage all customers to leverage this service. Like I mentioned, there is the free plan, which is available to all customers, and then there's a fixed SLA that has now been launched with the built-in automations and the 24/7 expertise that we can provide. So overall, just to summarize, our detection and response services are continuing to evolve and innovate. Our goal is to help customers continuously detect and protect their AWS workloads, enhance their security streamlines and automation. We're continuing to improve these services using generative AI, machine learning, and we're also enabling customers to aggregate the information easily that's needed to then go and innovate themselves as well. With that, thanks a lot, and please, if you can take the survey, that'll be very helpful.
You better, Bolt.